3.4. So let's look at another example. Number of dies on wafer. We derived a formula before, but this one we do not use that formula. So we will use some special property to give us the answer. So let's look at the question here. Example 2. Suppose the diameter of a wafer is n inches, and the number of dies of size 1 times 1 square inch. It's a square. Yeah. In order to make the calculation easier, so we just assume 1 by 1 inch size that can be produced from this wafer is m. We know m should be an integer, right? Yep. Good dies. Good dies. Yeah. All right. If we do precise calculation, so here you can see, so we do not use our estimate. So that pi, that dPW, die per wafer, the two-term formula, that's the estimate formula. But this one, we want to do precise calculation. It's possible based on the geometry. In a circle, the square inside a circle, there is some geometry property there. So if we use the geometry property, can we get the precise calculation? Yeah, but it is much harder, but we can. Yeah. All right. Which of the following numbers is most likely to be n? So here I only give you 4 options. So I ask you, which one is the most likely number for n? Multiple choice. Yeah. You just select the best answer. Okay. Yeah. So think about this question. Yeah. If you get the point, then it is very easy. Otherwise, it may not be easy. Yeah. So you can take some time to think about it. Then look at the analysis. Yeah. All right, so let me start the analysis. We need to find the key property. If you can observe this key property, you can get the answer easily. So what is that key property? So let's look at this picture. This is the situation we cut dies from a wafer. Okay, yeah. Here you can see what is the key property. Can you observe some key property here? Yeah. The die in the wafer are symmetric. There is a symmetry property here. So it's very easy, but if you get this point, symmetry property, then it will be much easier. Okay? Yeah. The symmetry property, so you can take a look, yeah, because, yeah, look at this. Horizontally, x-axis symmetric. Vertically, y-axis symmetric, right? Yeah. So you can see there are 4 quadrant 1, 2, 3, 4. Based on the symmetry property, the number of dies in each quadrant must be the same, right? Must be the same. So that's why number of dies should be multiple of 4. Yeah. But here, only one number in our 4 options, only one number is multiple of 4. That's 60. That's 60. Okay? Yeah. So we get an answer. Yeah. So if you observe this symmetry property, trivial, the answer. Yeah. All right. But next, let us do some discussion. Yeah. I like to do some discussion related to this question. Yeah. There are two questions some of my students asked me before. So here I like to explain a little bit. Yeah. One question. Yeah. So you may have the similar questions. Yeah. So one student asked me before in this way. Because if we look at the shape of the wafer, wafer, circular shape, the disc, standard disc, for that shape, when we cut dies, rectangular, square dies, we will have a lot of edge dies. So look at all these wasted edge dies. So a lot of dies are wasted. So then that student asked me, why not we just produce square die? How about that? Square die. In that way, if we set appropriate size square die, when we cut, square wafer, not square die, yeah. Then we cut dies in this way, then we can reduce the edge dies to the minimum, right? If we set the size appropriate, then we will reduce the edge dies to the minimum. How about that? Right? Yeah. Logically, this is a, reasonable question. Logically, right? Only by logic. But we cannot do that. We cannot do that. Yeah. Based on the background. Remember, I spent a lot of time to give you the background. Now we need to use that part. Based on our background, how do we produce wafers? Recall the procedure, the complicated procedures we went through. So there is one key step, CZ process. Remember the CZ, the polish chemist. CZ process. No? Yeah. Zokralski process. CZ process. Let's recall that. Okay? A seed, a rod seed, dip into the melted silicon, slowly rotate, pull. Remember that? All those pictures, diagrams. When you do that, rotate, so the melted silicon, monocrystalline silicon grow, attached to the rod, growing, bigger and bigger. How can you get the square shape, right? You can only get the cylinder shape. That fact relies on the monocrystalline silicon property. The crystal structure, attached to it, so they need to maintain the same crystal structure, right? Yeah. So that's the natural growing shape. All right. So you cannot get shape like that unless you cut it, right? You get a cylinder, then you cut it, Yeah. So you cut, right? Yeah. All right. So that's that answer. Yeah. That's that answer. The first one, CZ process. Okay. All right. So the second answer, second question, also pretty interesting. Second, another student asked me, because our goal, we want to get a maximum number of dies from a wafer, right? Yeah. And also that student noticed the fact, large number of edge dies are wasted. Yeah. Then he proposed a solution, improve the solution. Can we just move, for example, for this row, wave die, because we have some room at the left-hand side, can we just push a little bit this column to the left, then that column to the right, things like that. Left, right, shift. Yeah, so we can do some shift, right? Yeah, squeeze here and there, try to get a little more space. In that way, probably we can squeeze out a few more dies. How about that? That recommendation, yeah. So that's another, good suggestion. Yeah, apparently good one. But now, if we go back to our process, complicated process. Now, this way, even if, mathematically, geometrically, so if we only look at the question from the, geometric point of view, all right, yeah, geometric point of view, possible to get a few more dies out. Yeah, possible. But remember, a big goal in our process, goal, all right, reduced the manufacturing cost. When you do this way, okay, so when you geometrically you try to squeeze a few more dies out, then you need to, what do you need to do? When you cut dies, you need to do irregular cutting, right? You have to do irregular cutting because the dies are not aligned. They misaligned, right? So the dies misaligned. Okay, misaligned dies result in high cost, high production cost. So what's the point? You spend more money, okay? Spend more money. So we would rather throw away those useless edge dies in order to streamline the cutting process, minimize the cutting process, okay? So to get the minimum overall cost, manufacturing cost. So that's the answer. So for that reason, I give you a lot of manufacturing background so you can understand, questions like these two better. Yeah. All right, so let me finish the last video for our part C now.